Okay, we are going to now work on some of the rules that we can do with logarithms. So make sure that you print out your formula sheet at the bottom and watch the video going over that. But we are going to go through some of the rules. So let's start off with log 5 squared. Now you may be asking, what's the base? If you don't see a base, it's a 10. We are not worried about that right now. We are learning a rule that if I have a exponent, I can bring the coefficient, I can bring it down to be the coefficient. I also need to be able to go in the opposite direction. So if I have the coefficient in front, I need to be able to bring it up. So I need to be able to do both things. If I have log 5 squared, I can bring the exponent down in front. If I have 2 log 5, I can bring the exponent up. And we need to be very comfortable being able to go in both directions. Now, what if I already have a coefficient? What if I have 3 log 4 squared? Well, I can bring that 2 down in front, and I can multiply to get to be 6 log 4. Now if I take exactly the same question, I can also cross off the coefficient and multiply it by the exponent, which gives me log base 4, 6. So some of these rules we're just going to be working on in practice for more complicated questions. So notice these two things are equal to each other. These two things are equal to each other. So we're not necessarily going for answers right now, we're just playing around with the rules. So let's prove this rule. Log base 5, 5 to the 4. Well, what power do I have to raise 5 to equal 5? Well, 1. So if I bring my exponent down in front, and I use my definition of the log, what power do I have to raise 5 to equal 5? I know the answer is just 1. And 4 times 1 is simply just equal to 4. Let's see that differently. The same question. Log base 5, 5 to the 4. Well, what is 5 to the 4? Well, 5 squared is 25, times 5 is 125, times 5 is 625. So we have log base 5 of 625. Now, what power do I have to raise 5 to equal 625? 4. My answer is 4. So we're going to be able to we need to be able to use these rules all the time. Bring the exponent down in front, bring the coefficient up. Now we'll take a look at some interesting things that we can and cannot do. Okay, let's take a look at an interesting question. Log xy squared. Now the question is, can we bring this 2 down in front? Well, no. Let's take a look at another example. Log xy brackets around it squared. Yes, this 2 can absolutely be brought down in front. Let's take a look at another example. Log x squared y squared. Well, we're going to learn on the next page that if we have a multiplication, we can separate it into an addition. So log x squared plus log y squared. Then I can bring my exponents down in front. Now, if, for example, I were to expand this multiplication into an addition, I have 2 log x plus log y. But I've performed an expansion, and now I need to distribute in this 2 for 2 log x plus 2 log y equaling the same equation off to the right, 2 log x plus 2 log y. So this 2 at the top can absolutely not be brought down. If I wanted to, I could separate this multiplication into an addition of logs. So log x plus log y squared. Then I could bring this 2 down in front, which is absolutely not equal to any of the examples below. So be careful when you can and cannot move an exponent down in front, or if you should use the addition rule, which we're going to do in the next section, 8.4. So let's take a look at another example of bringing an exponent down in front. So if I have log 3 of x plus 2, well, that's an exponent of a logarithm, so I can bring that exponent down in front. And what I'll be left with is x plus 2 log 3. Now, I actually have to distribute backwards. So x times log 3 is simply x log 3, and 2 times log 3 is simply 2 log 3. Remembering, we cannot distribute into a log, but we can distribute a log into a binomial. So this is a simple version of a different way to represent the original question, and we'll be using it for all sorts of rules in the future. So let's take a look at another example. 3x log 7 minus x log 2. Well, these things both have an x, so I can remove a greatest common factor of x. Now, what am I left with? Well, I'm left with what I'm left with. I'm left with 3 log 7 minus log 2. So, being very comfortable, doing all the different rules, bringing our exponents down in front, distributing, and then also removing a greatest common factor. So let's briefly go through the change of base rule. If I have log 16 over log 4, well, on our formula sheet, I have a rule that says if I have this picture, I can simply turn it into log. Now, base 4 stays as my base, and the 16 is the thing that I'm logging. Now, what power do I have to raise 4 to equal 16? Well, the answer is simply 2. And if I typed this original, I better get the same thing. But the point of that was simply to perform change of base. So from now on, we're just going to do that rule. Let's do another one. Log base 2 16 over log base 2 4. Now remember, we can only use the rules on the rule sheet if we have the same base. We do have the same base. So this is simply equal to log the base 4 stays as the base and the 16 becomes the top. Notice the 2 is gone. The base is arbitrary. We don't need to include that base. So, for example, if I have log 2 4 and I want to change forms, I know that that's simply log 4 on top and log 2 on the bottom. Now, for example, let's say I wanted base 5 for some reason. Well, I can choose any base that I want to. So that is change of base. That is rule number 3 on our formula sheet. So let's take a look at one last rule. It's going to be rule 6 before we take a look at rule 4 and 5. So let's say I have log base 3 9 plus log base 9 2. So I need to have the same base. Right now I have a base of 3 and I have a base of 9. And that can't happen, or I cannot combine them. So if I need to have the same base, I'm going to choose a base of 9. Now what do I need to do to the 3 to get it to be a 9 like the other base? Well, I can square it. And if I square that, I have to square the thing I'm logging as well. Let's see that again in red. So my base is 3. I need to get it to be the same as the other base. So I square it. And if I square that, I have to square that. Now the other has a base of 9, so I can leave it. And if I square the 3, I get log base 9. 9 squared is 81 plus log base 9 2. Now I have a rule. If I'm adding logs, I can simply multiply the things that I'm logging. So I have log base 9, 81 times 2, which is log base 9 of 162. So we can perform a process called change of base, which manipulates a fraction of logs into a single logarithm, or we can take a single logarithm and turn it into a fraction of logs. And we can also perform methods to change what the base is. Now, this rule, the addition and multiplication rule, which we briefly talked about, we are now going to talk about in more detail in 8.4, which is going to be rule 4 on our formula sheet.